Have you ever wondered how AI can feel, well, both lightning fast and just painfully slow, sometimes in the same conversation? Today, we are going to look under the hood at the engine that's really powering modern AI. It's a system that's solving one of the biggest, most frustrating bottlenecks in the whole industry. So, yeah, let's get into it. I mean, you know the feeling, right? We've all been there. You send this perfect prompt to a chatbot, and you wait. And you wait. That little pause, that delay before the words start typing out, yeah, that's not the AI thinking in the way you might imagine. The real reason is a technical bottleneck, and it's surprisingly common. And this is the absolute key to the whole thing. The problem, the real bottleneck for most of these big AI models, it isn't about raw computing power. It's not the brain. It's actually a memory traffic jam happening right inside the GPU. And this is the exact problem that a really brilliant system called vLLM was built to solve. Okay, so to really get how vLLM works, its magic, we first have to understand the problem it's up against. And people in the field call it the AI memory wall. It's this performance barrier that pops up because of the very specific way these large language models process information. You see, a single request to an AI is actually two completely different jobs. First up is the prefill phase. Think of this like a sprint. It's super compute heavy, where the model just gobbles up your entire prompt all at once. How fast this happens determines that time to first token, how long you wait for that first word to appear. But then it immediately shifts gears. It goes into the decoding phase, which is much more like a marathon. It's generating the rest of the response one single token at a time. And this second part, the marathon, is where that memory bottleneck we talked about really rears its head. So what's causing this memory jam during the decoding phase? Well, it all comes down to something called the KV cache. The easiest way to think about it is like the model's short-term memory. It has to store all this essential mathematical context, the key and value vectors, for every single token in the conversation, just so it doesn't forget what you're talking about. And as the conversation gets longer, that cache gets bigger and bigger and bigger. And constantly having to read and write to this massive cache is what totally chokes the GPU. Now, the old way of managing this KV cache, it was just incredibly inefficient, like shockingly wasteful. To be safe, systems would just pre-allocate this huge, continuous chunk of memory, guessing at the longest possible response someone might need. This created two big problems. First, internal fragmentation. That's all the reserved space that just sits there, empty, never getting used. And then external fragmentation, where the leftover free memory gets broken up into these tiny, useless little pieces. It's literally like trying to park a giant bus in a parking lot that's only got spots for motorcycles. Just doesn't work. And this is where vLLM comes in with its absolute breakthrough. What's so cool about it is that the creators didn't invent some crazy new solution from scratch. No, they actually looked back and adapted a brilliant concept that's been a cornerstone of computing for decades. And this quote right here, it just nails the whole idea. Instead of reinventing the wheel, the vLLM team looked at how our computers, the operating systems on our laptops, have managed memory for ages. It's a problem that was solved a long, long time ago. And they just applied those exact same principles of virtual memory and paging to the GPU's KV cache. It is such an elegant, classic case of applying a proven solution to a totally new problem. So how does it actually work? Okay, let's just walk through it. Instead of grabbing one giant clunky block of memory, PagedAttention chops up the entire KV cache into these small, manageable blocks. Then it stores these blocks wherever it can find free space. They don't have to be right next to each other anymore. To keep track of everything, it uses something called a block table, which acts kind of like a table of contents for the memory. This means memory is allocated on the fly, only when it's actually needed. And just like that, all that wasteful pre-allocation is completely gone. And the impact of this, it's huge. I mean, look at this. With PagedAttention, memory waste just plummets to less than 4%. That is incredible. So on the exact same hardware, you can now handle way more users and much, much longer conversations. This fundamentally changes the economics of serving AI. It lowers the cost so dramatically that it allows smaller companies, even individual developers, to deploy these powerful models that honestly were once only possible for the tech giants. So you've got all this incredible new efficiency. What can you actually do with it? Well, for one, it makes something that was previously almost impossible a daily reality, serving dozens, maybe even hundreds of specialized models on a single GPU. And this is done with a technique called multi-LoRa serving. Now, the concept is simple, but it is so powerful. You start with one big base model, think something like a Llama 3. Then you create lots of these small adapter models that sit on top of it. Each one is fine-tuned for a super specific task. Maybe one's a legal expert, another is a Python coding genius, and a third writes amazing marketing copy. Now, instead of loading an entirely new, gigantic model for each different request, you just swap out the tiny, lightweight adapter. It's so much faster. And the result is just this massive leap in efficiency. I mean, look at the comparison. Traditionally, you'd need a separate, really expensive GPU for each of those specialized models. And most of the time, that GPU would just be sitting there, idle, wasting money. But with vLLM's efficiency, a single GPU can serve dozens of these lower models at the same time because they're all sharing the base model's weights. The utilization goes way up, and the cost savings, they are just enormous. But the world of AI, it never stands still, does it? The very efficiency that was unlocked by systems like vLLM has just paved the way for even more ambitious goals. So, just as we solved the big memory problem for text, a whole new wave of AI models started to emerge and, you guessed it, they brought a whole new set of challenges with them. Because the landscape of AI is changing, and it's changing fast. We're moving way beyond models that only understand text. Now, we're talking about models that can see and hear and generate all kinds of media. And this shift is really happening on three main fronts. First, we have true omnimodal models that can process images, audio, video, the whole shebang. Second, we've got totally new architectures like diffusion models for making images, which work differently from that one token at a time method we talked about. And third, a single user request might now need a whole complex chain of different models to get the job done. I mean, imagine asking an AI to make a video for you. You'd need one model to analyze your pictures, another to write a script, a third to generate a voiceover. That's what we call a heterogeneous pipeline, and the old architecture just wasn't built for that kind of complexity. So to meet these new, really complex challenges, the vLLM project had to evolve. Again. And that's when the team released vLLM Omni. It's an extension that takes the signature performance and memory efficiency of PagedAttention and brings it into this rich, demanding new world of omnimodal AI. It's really a fundamental redesign for this new era. And the way it works is pretty clever. It breaks the problem down into three distinct parts. You've got specialized encoders that are really good at handling inputs like images and audio. Then, the classic vLLM core, powered by PagedAttention, does all the heavy lifting for the reasoning and thinking part. And finally, specialized generators create the final output, whether that's an image, a voice, or even a video. It's this modular pipeline that's designed specifically for the future of AI. And in the true spirit of open source, the vLLM team has put out a call to the entire community to help build this next frontier. They know that the challenges of omnimodal AI are just way too big for any single team to solve alone. And they know that progress is going to be fastest when everyone is working together. Which, brings us to this final, really fascinating question. As all these technical barriers start to fall, and our AI systems really truly gain the ability to see and hear and understand the world like we do, the only real limit is our own imagination. So what incredible, creative, and maybe even world-changing things will we ask them to build with us next?